Day 724 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. In the day, we have question number 1391. Check if there is a valid path in a grid. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go on and check out that link in the description so you can get you some. Now let's see what the question says. You are given an n by n grid. Each cell of grid represents a street. The street of grid the street of grid of I and J could be 1, which means a street connecting the left cell and the right cell, 2, which means a street connecting the upper cell and the lower cell, 3, which means a street connecting the left cell and the lower cell, 4, which means a street connecting the right cell and the lower cell, 5, which means a street connecting the left cell and the upper cell, and 6, which means a street connecting the right cell and the upper cell. So they give us nice visual representation of each street. This is street 1, street 2, street 3, street 4, street 5, and street 6. It says you will initially start at the street of the upper cell, which is 0, 0. A valid path in the grid is a path that starts from the upper left cell, 0, 0, and ends at the bottom right cell, n-1, n-1. The path should only follow the streets. Notice that you are not allowed to change any street. Return true if there's a valid path in the grid or false otherwise. All right, y'all, so that sounds simple at first, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in our input grid, we have a 2D array of integers. First array being 2, 4, 3, next array being 6, 5, 2. The output is true. Explanation says, as shown, you can start at cell 0 and visit all of the cells of the grid to reach n-1 and n-1. So just to break this down one step further, you can see we got the output of true because this is a valid path. We could get from this cell to this cell following this street, right? Boom. So before we get into an example 2, this is just, you can already see this is not a valid path because you see how the streets are not connected. Up here, you see how the streets are connected, which makes it a valid path. Now, remember, each one of these numbers represents a different way that the street is structured, right? So remember, 2 is going to look like this vertical line, right? Boom, that's street 2. Then, what we have? 4. So street 4 is right here. Boom. So then street 3 is right here. Boom. So you can see what it actually looked like. But this is just the top row. So remember, this is not the actual path. This is just the top row. So we have 2, this vertical line. Then we have a 4 right here, right? The 4 right here. Boom. Then we have the 3 going this way right here, right? So that's the top row. Then this array right here represents the bottom row. So as you can see, this would be 6, 5, 2. Once again, we already know 2 is a straight line because that's how this 2 is. But 6 and 5, let's look at 6 and 5. 6 and 5 is like this. Boom, this is 6, this is 5. And once again, this is 6, this is 5, right? So this right here is the top row. This is what the top row of streets look like. This right here is what the bottom row of streets look like. And in the end, when we follow this street path, we're able to get to our goal right here. Boom. So now let's take a look at example 2. So in example 2, we have our input grid equals a 2D array of integers 1, 2, 1, 1, 2, 1. The first array is 1, 2, 1, and the second array is 1, 2, 1. The output is false. It says, as shown, you the street at cell 0, 0, it is not connected with any street of any other cell, and you will get stuck at cell 0, 0. So as you can see, 0, 0 is 1. It's just a horizontal line like this. Boom. This doesn't connect to any other street, so our path ends right here in this cell. So we return false because it's impossible to achieve our goal of reaching this cell and this cell. Boom. So now let's take a look at example 3. So in example 3, we have an input grid equals a 2D array of integers 1, 1, 2. The output is false. It says you will get stuck at cell 0, 1, and you cannot reach cell 0, 2. Right? So as you can see, we have 1, 1. We already know the 1s are a vertical line. Boom. So I mean the horizontal line, excuse me. So we have two ones. So we almost make it to the last cell, but then boom, we got a vertical line. We run into one of these. So we have, imagine two of these going this way, but then over here we run into one of these and we get blocked and we can't stop anymore. Boom, so that's why the output is false. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult. Now, first thing we need to do is we need to get the dimensions of the grid. So we're going to say let m equal grid dot count, boom, comma, we're going to say n equals grid square bracket 0, come outside of that and say dot count. So this is going to get us the rows. This is going to get us the columns. Boom. Now, sorry y'all, come underneath this. And if there's only one cell, then it's trivially valid. So we could say if m equals 1 and two and signs, n equals 1, then we can open up the brackets and we could just return true right away. Boom. Now we need to get our direction vector. So 0 is going to be left, 1 is going to be right, 2 will be up, and 3 will be down. So we'll come underneath this, and we will say let dr equal square bracket 0, 0, -1, 1. Boom. Then we're going to come underneath this. We're going to say let dc equal square bracket -1, 1, 0, 0. Boom. Then we're going to come underneath this. And the opposite direction mapping, if you go in the direction D, then the op of D is going to give the direction that you came from. So we're going to say let op equal square bracket 1, 0, 3, 2. Boom. And for each street, we're going to type 1 through 6 to find the two directions it connects. So example 1, type 1 will connect left 0 and right 1. So let me show y'all. Let's come underneath this. We're going to say let connections square bracket. We're going to open up some parentheses. Oh, excuse me, put the square bracket, open up some parentheses. It's going to be a tuple, so it's going to be int, comma, int, two integers. Come outside of that, and we're going to initialize it by opening up some more square brackets. We're going to say, open up the parentheses, 0, 1. Boom, sorry y'all. And that is going to be type 1. Then we'll say comma. Then we'll say parentheses 2, 3. Come outside of that. Or we could copy and paste it. Let's copy and paste this. Or let's put the comma 2 and I'll copy and paste. Boom. Then we're going to come underneath that. That's type 2. Then with this right here for type 3 is going to be 0, 3. Boom. Come underneath that. For type 4 is going to be 1, 3. Boom. Come underneath that. Type 5 is going to be 0, 2. Boom. And come underneath that. Type 6 is going to be 1, 2. Boom. 1, 2. Boom. Now we're going to simulate walking through the grid starting in a given direction. So for that, we're going to create a helper function. So come underneath this square bracket, we're going to say func walk, open up the parentheses, underscore. We're going to say start dir, colon, that's going to be an integer. Come outside of that, we're going to return a boolean. Open up the brackets, and we're going to start at the top left corner. So we're going to declare a variable called r, set that equal to 0, boom, comma c, set that equal to 0, boom, comma D, set that equal to start dir. Boom. Then we'll come underneath this and we'll say while true. We'll open up the brackets and we'll move one stop in the current direction. So we'll say R plus, sorry y'all, plus equals 1, or excuse me, R plus equals D, sorry y'all, DR square bracket D. Then we'll come underneath this. And we'll say C plus equals DC square bracket D. Boom. Then we'll come underneath that. If out of bounds, then it's an invalid pass. So we'll come underneath this and we'll say if r is less than 0, or two vertical lines are, sorry y'all, r, hold on, r is greater than or equal to m, or two more vertical lines, c is less than 0, or two more vertical lines, c is greater than or equal to n, then we could open up the brackets and we could just return false, just like that. Boom. Now, if we loop back to the start, then it's an invalid cycle as well. So we'll come underneath this and we'll say if r equals 0 and two and signs c equals 0, then we'll open up the brackets and we'll return false. Boom. And then get the allowed directions for the current cell street type by coming underneath this, and we're going to say let, open up the parentheses, a comma b. We'll set that equal to connections square bracket grid. Come outside of that, we'll say square bracket r square bracket c. Come outside of that, we'll say -1. Boom. Then we're going to determine that the direction we entered this cell from by coming underneath this, and we'll say let entry equal op square bracket d. Then we're going to check if the street allows entry from this direction. If yes, we'll continue in the other connected direction. So we'll come underneath this and we'll say if entry equals a, then we'll open up the brackets and we'll set d equal to b. Boom. Else, we'll come right here on this else, on this if, and we'll say else we cannot enter this cell properly, then it's invalid, so we could just return false. Boom. And if we reach the bottom right cell, then a valid path has been found. So we'll come underneath this and we'll say if r equals m minus 1 and two and signs c equals n minus 1, then we could open up the brackets and we could just return true right there. Boom. Now we need to get the two possible starting directions from the first cell, because remember that was the helper function. So we still are going to need to call that. So first we'll come right here and we'll say let, open up the parentheses, a comma b equal, we'll say connections square bracket grid, come outside of that square bracket 0, then another square bracket 0, come outside of that, we'll say -1. Boom. Now we're going to try both possible starting directions. If either leads to the destination, then we'll return true by coming underneath this, and we can say return walk, open up the parentheses and pass in a, or two vertical lines, we could we'd say walk, open up the parentheses and pass in b, y'all. Boom. That should be all that she wrote. Let's give it a run. Make sure it runs properly before we submit it. Okay, and we have an error, invalid. Oh, sorry about that, y'all. So this should be D. This C right here, we're going to change that to a D. And then we're going to run it again. See if that did it. Ooh, we got the wrong answer. So when we get the wrong answer, most of the time, that means somewhere the math is not math. And so give me a moment while I go over the math. It's a lot of numbers, so might take a while. Let's see, I'll make sure these numbers are right. Because if the numbers aren't right, you will get the wrong answer. And I think right here, this DC square bracket should be a D and not a C. So let's see, even though that wasn't a number. Oh man, but that wasn't even what was wrong. So we still got the wrong answer. So let's continue going, seeing if we could see where it came from. So boom, boom. That seems good. That seems good. That seems all right. Okay. Okay, right here. Skip the part. So we have an else. So first it should be if. Then right here, this should be an else if. Boom. Let's clean this up before we fill that in. Now on this else if, we need to handle, we're going to say else if entry equals B. Then we're going to set, come right here and set D equal to A. So let's see if that's did the trick. And it's accepted, y'all, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. And look at that, y'all. 4 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, y'all, I hope y'all learned something today. And matter of fact, before we go, make sure you get one more look at the code. This is the top. This is the middle. This is the bottom, y'all. And yeah, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.